This is the review for tomorrow's probability test. It looks very much like the test that you're going to take. It starts off with simple probability, or just finding a single event, moves to drawing a relative frequency, and then on to possibility diagrams, tree diagrams, and some probability with spinners, compound probability. So we're starting with simple probability. So question number 1. A book is chosen at random from a shelf that has 6 history, 3 drama, and 5 mystery. What is the probability of choosing a drama? So what is the single fraction, class?
3/14.
3 out of 14. Yes, very good. 3 out of 14. A student, number 2, answers true 3 out of 8 times on a quiz. What is the probability of the student answering false? So if it's 3 out of 8 is true, false would be
8 out of 3.
5 out of 8. There's 8 questions on the quiz. So if it's true 3 of the times, it will be false 5 of the times out of 8. In a recent board poll, 38 responded approve and 12 responded disapprove to a city tax vote. So the city board was voting on something. What is the relative frequency, probability, based as a percent? That's what it's asking. So what is the relative frequency of disapprove responses? Give your answer as a percent. Well, disapprove was 12 out of, what's the total here? 50. So give this answer as a percent. Is that a percent?
No.
No. Could we make it easily into a percent?
Yes.
By making it out of 100. So what would I do with my numerator there? Times it by 2. Very good. The denominator multiplies by 2. The numerator multiplies by 2. Now we have 24 hundredths. What percent is that?
24.
24%. Yes, any number out of 100 represents a percent. So we've taken our fraction, 12/50ths, and made it into the equivalent 24%. Good job. Mrs. O'Malley wants to have 3 children. Draw a tree diagram to show the possible boy-girl combinations of children she could have. What do we always do first on a tree diagram?
You label.
Label the top. Yep. So child 1 or kid 1. We'll call it kid 1. Kid 1. She could have either a boy or a girl. So separate them out. Give yourself space here. Child 2 or kid 2. Yep. She could have what? Boy or a girl. Boy or a girl. Yep. So we're filling it in. Kid number 2. Headings, headings, headings. Now we're having a 3rd child. She could have a boy or a girl, boy or a girl. So we're filling in boy or a girl all the way down our tree diagram. 2 branches off of each prior branch. Because yes, when you have a child, you could either have a boy or a girl. So kid 3. Then our outcomes. We could have boy, boy, boy. Or we could have boy, boy, girl. So I'm just following the branches. We could have boy, girl, boy. Or we could have boy, girl, girl. We could have girl, boy, boy. Or girl, boy, girl. We could have girl, girl, boy. Or girl, girl, girl. So there's all my 8 outcomes. When you have 2 possibilities 3 times, 2 times 2 times 2, it gives you 8 total outcomes. So I'm going to let you answer part B on your own. What is the probability of Mrs. O'Malley has 2 girls and 1 boy? You can answer that now on your own. Let's go to question 5. The types of yogurt flavors chosen by 80 people are at a party. Good to know the total. They are summarized below. The flavor: vanilla, chocolate, strawberry, macadamia, and raspberry flavored yogurt. Complete the following table by finding each relative frequency. I'm going to read all the parts here before I answer that. Part B, what is the probability that the next person at the party will choose macadamia flavored yogurt? Give your answer as a percent. And part C says, looks like we're going to be drawing a graph. Present the relative frequencies in a bar graph using percent. So since part B and C both say using a percent, I'm going to answer my relative frequency. Instead of vanilla, 6 out of 80, I'm going to convert that to the percent. So you guys have calculators, right?
Yeah.
6 out of 80 is what percent? How would we do that? So you changed it to the decimal, Lindsay, yes. 0.075. What percent is that? So if I have 0.075, what percent is it? 7.5%. Yes, very good. And 20 out of 80, and I'm not even going to put the fraction in there because there's not a lot of space, but chocolate would be 20 out of the 80. 20 out of 80 is what percent, ladies? 25%. Very good. Changing the fraction to a decimal. 8 out of my total 80. 8 out of 80 is what percent? 10%, because it's 1/10. Yep, it's the decimal 1/10. Here we had 25 hundredths. Here 6/80ths was 0.075. Remember, changing a decimal to a percent. So we're doing FDP here, a little FDP practice. Fraction to decimal to percent. Macadamia is 30 out of 80. What percent is that? 37.5. Very good. It would be 37.5%. And then raspberry, 16 out of 80 would be 20%. Yes, it gives you the decimal 2/10, which we changed to moving it 2 places to the right, 20%. Okay, what is the probability that the next person at the party will choose macadamia? Give your answer as a percent. Well, there it is, right there in our chart. It is based on the probability that's already occurred. This is our experiment. We're keeping track of what kind of yogurt people chose at a party. So our next probability is based on what's already occurred, 37.5%. Present the relative frequencies in a bar graph. So you all have rulers, correct?
Yes.
So we're going to use percents. That percent is going to go on the y-axis or the x-axis? The y-axis, yes. So our relative frequency, and it's going to be hard to write that here for me, but you have a little more space. So you have to write relative frequency and then a percent symbol because we're keeping track of it in percent. If we were keeping track of it as a fraction, I would write nothing. I would just say, I wouldn't have to put the percent sign. If we were showing it as a decimal, I might say in decimal. So that's our y-axis. Our x-axis is going to be flavors, yes. And then we have to make a bar for each of our flavors. And there are 1, 2, 3, 4, 5 of them. So probably need to make them 3 wide with 1 space in between. That's what I would say. So I'm going to leave a space and then make my first flavor vanilla. And I'm just abbreviating VAN. And then leave a space, 3 bars wide, it's chocolate. Leave a space, 3 bars wide would be strawberry, and again I'm abbreviating. 1 space, 3 bars wide, next would be macadamia, MAC. 1 space, just fit on here. 3 wide would be raspberry. So yes, we've used our entire x-axis. We've got our spacing on the x-axis. Now we've got to make sure that our highest frequency, our highest percent is only 37.5. Needs to be the majority of the way up the y-axis. Probably going to count by, every 2 would be 5%, I think works. So then that would be 10. This would be 15. Yes, I'm writing over the top of mine, sorry. But you probably have more space than me. 20%, 25. I'm going to erase my label. Yeah?
When they decide how to, like what rate they're going to put on the y-axis, because you're going by times, what if they had chosen to go by a different?
Oh, 4, 6, just as long as your 37.5 is more than halfway up the
And it's
axis.
a consistent equal amount?
Yep, it has to be equal intervals. Very good question. 35 and 40. So these are my percents. So my 37.5 is going to go the majority of the way up the axes. So now you have to use a ruler and make your bars. Do they touch? No, because it's a bar graph, not a histogram. Hint, hint, hint. The one on the test is a histogram. So it is a histogram on the test. It's a bar graph here on the review. So my vanilla was only 10% or 7.5%, way down here. So it's going to actually be halfway between 5 and 10 is 7.5. So there's 7.5 for vanilla. Chocolate was 25%. So going up to 25. Whoops. Strawberry was 10%. A bit more than that vanilla one. You can see I'm using a ruler. Macadamia is 37.5. That's going to be the nice tall one. So that's going to be halfway between 35 and 40 is 37.5. So using 5s was actually a good idea on the axes there. And raspberry would be 20%. So definitely I'm only making a bar graph, not a histogram. They're not touching. Histograms always have intervals of numbers on the x-axis. These are categories or just individual kinds of things, which makes it a bar graph. What's the one thing we've forgotten? Title, very good. And yes, I'm going to call this yogurt flavors. Or yogurt choices, but yogurt flavors is good. People picking yogurt, something along that lines. So we've labeled our x-axes, we've labeled our y-axes. I had to take mine off because you couldn't see it there, but it did say relative frequency. So maybe I'll write it here. And since I was graphing it as percents, you should have the percent sign there. So on to number 6. Susan randomly draws a card from 3 number cards, 2, 4, and 6. After replacing the card, oh, so it's back in there. Independent probability. Susan randomly draws another number card. The sum, ooh, sum, bolded there. Sum of the 2 numbers, adding them together, adding the 2 number cards is recorded. Use a possibility diagram, which is just a fancy word for a table. You have rulers. You could make it with a nice ruler there. I just might make it with a ruler here. So I have the possibility of getting a 2, a 4, or a 6. Okay, so I can get a 2, a 4, or a 6 on both of my draws. So adding them together, 2 plus 2, 4 would go in this space. 2 plus 4 would be 6, and 2 plus 6 would be 8. 4 plus 2 would be 6. 4 plus 4 would be 8. 4 plus 6 would be 10. 6 plus 2 would be 8. 6 plus 4 would be 10. And 6 plus 6 would make it 12. So there's the sums. Similar question on the test tomorrow. Read carefully. Using your answer in A, what is the probability of forming a number larger than 5 but less than 11? I'm going to let you answer that one on your own. Take a moment and answer that one. Going on to question 7. Roma surveyed 40 people at random at work one day and learned that 16 of them favored working 7:30 until 4:30 most. What is the probability that everyone at that workplace would favor working those hours? Well, it's based on the probability you already have. It would be 16 out of 40. Darn, not one of my choices. 16 out of 40. So I'm going to let you figure out what decimal that is and choose the right answer there for number 7. Luke has a spinner that is divided into 8 equal parts. If he spins the spinner 80 times, wow, Luke, too much time on your hands. How many times can he expect that the arrow is going to land on a consonant? Well, N is a consonant, and T is a consonant, and R, and S, and N. 1, 2, 3, 4, 5 out of 8. But he's not just spinning it 8 times. He's spinning it 80 times. Well, that's an easy fraction 1 equal ratio problem to find. So I'll leave that one for you to finish the equal ratio problem on your own. Question number 9. A bag contains 2 white golf balls and 1 green golf ball. Another bag contains 1 red cube and 2 yellow cubes. Alan draws a ball from the first bag and a cube from the second bag. Use a tree diagram to represent the possible outcomes for drawing a ball and a cube. So first drawing a ball which has 2 whites and a green. So I'm starting with either a choice of white or green. Are they equal? No, 2 whites and 1 green. So 2 out of 3 of them are white, 1 out of 3 of them are green. So this is my first choice, picking a ball out of the first bag. Then Alan draws from the second bag a cube. Are they equal? 1 red and 2 yellows. Not equal, so you have to put the fractions on here. 1 red, 1 out of 3 of them are red, 2 out of 3 of them are yellow. So you can choose a red or a yellow. 1/3, 2/3. So that's picking the cube. There's my heading and outcomes. So white with red, and that would be 2/3 times 1/3, which would be 2/9. White with yellow, that would be 2/3 times 2/3. You can put that answer there. Green with red, and green with yellow. And I'm going to let you finish answering the fractions on your own there. So part B, I'm going to let you answer that one on your own as well. Find the probability of drawing white and then red. White and then red. Part C, is this compound, meaning 2 things happening, event, an example of independent or dependent events? Does picking a ball have anything to do with picking the cube? Does it affect it? No, right guys? Because it's 2 separate bags. So it's independent. Good answer. It's independent. Because the first event does not affect the second event. So that's independent probability. I didn't change my denominators like we did in yesterday's video. So I bet the next tree diagram, oh, yep, without replacing it. Tracy's gonna pick stamps. She must be a stamp collector. Tracy has 5 USA stamps called U and 2 Singapore stamps represented with an S. So it's telling you what to use for your letters, U and S. Singapore for S, United States gets the U. She randomly selects 2 stamps without replacement to give to her friend. So she picks a stamp and keeps it in her hand. Doesn't put it back in the pile. Draw a tree diagram to represent the possible outcomes. Well, she could either pick a US stamp or a Singapore stamp. So this is first pick. Are they equal? 5 US stamps and 2 Singapore. So what's US, guys? 5 out of 7. 5 sevenths. So Singapore would be 2 sevenths. Okay. So then, second pick. What could she pick? A US or a Singapore? A US or a Singapore? So second pick, same choices only. Now we've got to put the fractions on there, knowing that she's not putting the first one back. So this U here says, oh, she picked a US stamp. How many US ones are for the second pick left? How many are left? 4 out of? 6. She took one out of the pile, right? So now there's only 4 out of 6. Both the numerator goes down and the denominator. So she's picked a US stamp. Now she's gonna, so now there's only 6. Now she's gonna pick a Singapore stamp. There's still 2 of them left. 2 out of 6. And yes, 4 6 plus 2 6 equals 1. So I do have all my possibilities here in this branch. So, starting down at the bottom, she picks a Singapore stamp first. Then she goes to pick a US stamp. So I know my fractions are all going to have 6 with the second pick. If she picks a Singapore one first, how many US ones are still left? 5 of them. Because she picked Singapore first. That's what this says. But Singapore would give me 2 sevenths for the first one and 1 6. Very good. 1 6 for the second one. So now, US, oh, here's my outcomes.
I have a quick question, I'm sorry. Do they always, when they're doing this on a test, regardless, there will always be an outcome column?
Yep, always.
Always, okay.
So US would be 5 sevenths times 4 sixths, which would be 20. Oh, very good. 20 over 42. Whoops, I must have hit something. 20 over 42. So US and then Singapore would be 10 out of 42. Singapore US would be commutative property there. 10 out of 42. Singapore would be 2 out of 42. Now I know I've done that correctly if I add my fractions here and they add to 42 out of 42. Let's make sure. 20 plus 10 is 30, plus 10 is 40, plus 2 is 42 out of 42. Make sure you do that on the test. You've gotten all 100% of your possibilities in your tree diagram. So what is the probability that Tracy selects 1 Singapore stamp and 1 US stamp? 1 Singapore stamp and 1 US stamp.
Oh, 20.
Why 20 out of 42? Because she could get Singapore US plus US Singapore. So you've got to add those together, which is 10 out of 42 plus 10 out of 42. It just says 1 Singapore. It doesn't say what order, and 1 US. So you got to do both orders. So there are a total of 20 out of 42 possibilities. What is the probability that Tracy selects 2 USA stamps? So go back up on your tree diagram. What's UU? 20 out of 42. What's the probability that Tina or Tracy selects both stamps from the same country? What does that mean? US, US plus SS, Singapore, Singapore. We know that's 20 out of 42. Singapore was 2 out of 42. So 22 out of 42. Is this compound event an example of independent or dependent events? Did the first event affect the second one? Once we took a stamp out, did we still have the same number of stamps? No. So the first event did affect the second one. That's dependent. That's dependent probability. Dependent events. Is that the end? So there were a few that you had to fill in on your own. Make sure that you go back and do that if you haven't already done so. And that's it for today's video.